Okay, let's do the dividing. Dividing the radicals. We just do the square root, right? So we did add, subtract, and multiply last time. Then we are on the section 9.5, page 43 for division. So let's do one term divided by one term first. Okay, so for a crazy number divided by crazy number. And I'm going to skip this one, don't worry about it, because if it's in the class, we do more with the calculators. But here, let's just do it. Okay, so let's see. When we do the dividing, and for the first one, 10 divided by square root of 5. That's not a good number. And crazy number, you cannot just do the dividing, okay? But remember, the rule says what? We don't want to have radicals in a denominator. So how can we get rid of radicals in a denominator? That's the point, right? Then the denominator is a crazy number. It's an irrational number. So we want to make it without radicals. That means would be rational numbers. So then we call it what? Rationalize the denominator. It means what? Division. So how can we get rid of it? Okay, we say we can do that by multiply its twin, right? If we do that, let's see. If you multiply one top, you have to multiply the bottom and vice versa, right? Because this value is 1. So it doesn't impact the original value. So if we do that, square root of 5 times a square root of 5 is what? 25, square root of 25 is 5, right? Because you have a twin, they show the root, that would be 5. The top, it will be 10 square root of 5, right? Then you cleaned up, you have what? 2 square root of 5. That will be your answer for division. Okay, so when we do what? Dividing the radicals, mono to mono, right? And we simplify them. Just follow that 4 rules. Remember the 4 rules? Right? 4 rules was saying, we'll keep repeating this part. Okay? In the middle of your paper, 4 rule is saying you don't want a negative, right, inside the radical. That's how we do the simplifying, add, subtract, multiply, and divide for all the crazy numbers. Okay? Then we say we don't want to what? No roots inside the radical. If you have roots, you have to show the roots outside the crazy thing, right? We don't want to have what? Fractions inside the radicals, right? Then we don't want to have no crazy number, no radicals in the denominator. We keep repeating this, then hopefully you remember them. Okay? So that's how we do add, subtract, multiply, and divide. Let's take a look at the second one. Say 3 divided by 2 square root of 7. Right? It's a mono and mono division. You don't want to have radicals in the denominator. What do we need to do? We can multiply its twin. You don't have to worry about 2. 2 is a real number. Main thing is we don't want to have a crazy number square root 7 there. So to be able to eliminate that, you need to multiply a square root 7, right? So for the denominator, square root 7, 2 of them, that becomes 7. 2 times 7. Top is this, right? So your answer would be 3 square root 7 over 14. That's how we do the division, mono to mono. Okay, then next one, if 4 divided by cube root of 2, what do you think? You have a cube root, right, in the denominator. Then for cube root, you want to take a root out to get rid of crazy thing. You need to have a triplet, right? So you need to do what? You have 1 here, you need 2 of them to make a triplet, right? So you need to multiply by that. Then what do we have? The bottom would be cube root of 2 to 2. That would be 2, right? That would be 4 cube root of 4. Then you have to clean up. That would be what? That would be 2 and cube root of 4. So that would be your answer that way. Right? Okay, let's try this. Not on your paper. Similar to this. So if I have 4, and I have 4th root of 2, right? What do you think? How can we get rid of crazy things on the bottom, right? So for the 4th root, you need to take the root out of what? Quadruple, right? 4 of them. So you can show the root. And this one, you already have 1. Then how many more you need? 3 more. Is that right? Okay, so for the bottom, you have total 4 of the 2. And for the 4th root, the root would be just what? 2. Is that right? So you have 4th root of 8. Then you cleaned up. So you have 4, 2, and 4th root of 8. That's how you do the division, right? That's what we are doing. We are doing the division for those crazy numbers. So we start simple, mono to mono. We just divide 1 term to 1 term. Okay, then what happens if you have more terms, more than 1 term? Okay, so the idea is this way. So you look at your page 43 on the bottom for the process, how we usually do. Okay, so we are on the part 2. If we are going to divide more things, okay, maybe 1 term, maybe 2 terms. Okay, so that's how we do. You can separate them. Okay, let's see some examples in as well. So you can use the quotient rule, right? Use the quotient rule to write as 1 radical, like this, right? And you will reduce it if possible right? To keep the number smaller. We are talking about is we say to simplify. That means you want to keep the inside of the radicals as simple as possible, right? So if you look your page 44, the first example we have, say 15, square root of 15 divided by 3, that would be what? See, we will use the quotient rule to write as one radical. So this one is 15 divided by root of 3, right? Two radicals, but can we combine them? 15 to 3, right? So we cancel out, we end up what? Just a single radical without a radical in the denominator. That's what we are talking about here. We said, remember this? We say you can, if you have same roots, right? All the nth root, radical, second square root, or cube root, then you can combine them or you can split them, right? That's what we are talking about. That's the quotient rule. Then you can combine them. This way, when you divide, you actually doing the dividing, but when you combine them, it cleaned up itself inside, then your result will be there for you. Okay, you can use the rule to do that. Then, second method, okay, so sometimes, see, this one is combine them, right? This one, you combine them. Another one is use the same thing, use the quotient rule to write as what? Separate one. You write you separately, right? And you simplify them, okay? Simplify each radical as possible. So this one is talking about what? Sometimes they are together, then you separate them to make it easier to divide and simplify. Okay, so you can see for the example, let's see, we have before, right? And that was on your previous one. Let's see, that would be on the simplifying radicals. That would be on your example. Okay, on your page 40, right? We have this. So we have like 81, right? So what do we do? So instead of together, we separate them. Okay, then we do this. That's what it is saying. You can use that kind of rule to do that. Okay, so next one is what? Another way is called what? Rationalize the denominator. That's what we were doing, mono to mono. If you have a mono in your denominator, then you rationalize it by multiply its twin or triplet or quadruple, right? To rationalize denominator. That means you are doing the division. Then after that, you will reduce your fraction. Like here, after that, you reduce them. That's how we do the division. Is that right? Okay, let's come back to the page 44. So, like 6 square root of 3 over 5 square root of 2, mano to mano, right? So, when we use this idea, rationalize the denominator, then get rid of radicals in a denominator to make it a rational number. So we call it rationalizing. Okay, so we will do what? Multiply. You don't have to worry about 5 because that's a real number. Only crazy number we don't want to have there. So you can multiply by that, right? Then the twin would be, the root would be 2. So 5 times 2, 6 times. Then square root 3 and square root 2, both are square root, same kind of roots. Cube root, fourth root, or square root. Then you can put together inside. You don't want to separate them to write the two things. Okay? Then after this, we want to reduce the fraction. So you will do what? 3 square root of 6 over 5. That's how we do the division for the crazy numbers. Right? Then at the same time, when we do the division for the crazy numbers, we call them what? Rationalize the denominator. They are same concept. Okay? So, if we have this one, right? If you divided 2 terms divided by 1 term, however, just like your polynomials, when we do the division, we can only handle 1 term to 1 term at a time. Okay? So, when we do it, we can only do what? Mano to mano to simplify our radicals right now, right? So, what do we do? Bino to mono, so you distribute it this way, right? You need to just handle individually, it will be much easier. So that will be 1. Then you cannot divide, but you have to check and follow the rules. 4 things you have to follow. Make the inside of the radicals as simple as possible. You always have to check. Just like you check if you make the fractions as simplest form, right? So this one will be 2 times 3 times 3, right? Then you have a root of square. You have to show them outside instead of leave them inside. So you have 3 square root 2 and 6, right? Then you simplify your fraction. So that will be 1 minus 2 over 2. That's how you will do it. Okay? And next one is a similar, and we just skip it. Okay, you can do it on your homework to practice. They are the same, right? So bino to mono, you just deal with mono at a time. If you have this one, okay, so same thing, we do what? Rationalize the denominator to eliminate your radicals in a denominator for square root, so you multiply its twin, right? So what do we have? We have 6 and square root of 60. And you need to check if it's the simplest form, then that will be 2, 2, that's 4, 3, and 5. Do your trees, right? Then you take the twin out, that will be 2 square root of 15 over 6. Is that right? So we cancel this, that will be square root of 15 over 3, right? And next one is the same thing as this. We just skip it. In class, we let you practice on. So you practice on your own. And next one, 7 and 12, right? So how should we start? You have fractions inside the radical, so you can split them, right? Like this one. Use the quotient rule. You split it. Then, because it's not a good number, like early on, right? It's not good number like those. You can just finish up. But here, you need to do what? Multiply its twin, right? Then the bottom, you have 12, right? Then top is 84. Then you need to check. 84, do your trees, 2, 2, that would be 4, 21, 3, and 7, 12, yes. Right? Then you have to take the twin out to show the root. That would be what? 2 square root 21 over 12. Right? Then we cleaned up our fraction, and that would be square root 21 over 6. That would be the simplest form for a radical. Right? And next one, if it's cube root, 40 over 9. So fractions inside the radicals, you split them, okay? So you can handle it individually. So this one, you can say, oh, I time another, say, cube root of 9, then you can have a 9 as a root. But the number is very big, right? 81 you times 40 on the top. It's huge. However, you don't have to use this if you take the deep look, all right? So that is that 3, 3, right? It has 2 of them already for the 3. So for triplet, all you need to do is just do one more. Make a number smaller. Instead of 999, huge number 81 times 40 on the top. Right now, you only need one of the 3. Right? Then you make a 3 here. Instead of multiply, denominator become 9. Now, if it's cube root of 3, 3 of them, it's only 3. Then make a top number much smaller. Right? So that would be cube root of 120. Then you need to simplify. 120 is what? 2 times 2, that's 4 times 2, 3, 5. Am I right? Let's see. 2 times 5 is 10. That's a 30. 30 times 4, yes. Okay, so cube root. So I can only take a 2 out. Oh, no, I need 3 of them, right? Because it's a cube root. So you need a triplet. So you have what? 3 cube root, 2 outside, 15 inside. Right? Then over 3. If you multiply 9, you will end up same thing. If you cleaned up, then you cancel out your numerator and denominator. It ends the same. Right? What are we doing? Think about it. We are doing what? Dividing the radicals. So far, we have been doing what? One term divided by one term, mano to mano. Or we have fractions inside the radicals, then we split them, then we rationalize them. Right? So we check on the numbers first. Now we are going to do the variables. Okay? So for the first one, I'm going to split it. I'm going to, not split, skip. Okay? We just do the following. They are the same. Okay? So it's the same thing as the next one. You have 6x squared y over square root of 3xy. It's the same thing. You write it, instead of horizontally, you write it what? Vertically. Okay? Then we say, okay, both are square root. So we can just put them together. Sometimes you split them, sometimes you put them together. You just have to play around, see, it will make situation easier to handle. Okay, so this cancel out, that would be 2. Oh yeah, we can cancel out 1x and y, cancel that out. Right? Then what do we have? We end up is what? 2x. That's what we have. Right? Because when we combine them, it cleaned up, inside already. Then you don't have a denominator anymore. So that would be your answer. And next one, if you have, that would be what? 18x to the 5th power over 12x, right? A fraction. Before we split them, it's easier, we just clean up if we can. We do that first. Okay, so divided by what? 6. That would be through 2. This one would be x squared, right? Then what do we have? Then we will have, wait, that's not 18, I cannot really see it. It's a 15, right? If it's a 15, I divide it by what? 3. So that's 5, that's 4. Is that right? So what do we have? We have 4 here, 5x squared here, right? Then what do you think you would do next? You will split them, right? So, when you cannot simplify anymore inside for a fraction, then you split them. Then you rationalize them, right? So square root of 4 just happened 2. Then this one, x is a twin. You take them out. So you have a square root of 5 left. Wait. Oh, man. I was checking my marker. It's not right. So that's 4. That's 4. So I should have a square here. Right? So let's look at the next one. If you have b over cube root of 2b, right? So what do you think? How should you start? You have what? Radical in the denominator, which is undesirable. We have to rationalize it, make it go away. To make it go away, we need a cube root, right? We need 3 of them, triplet. So we need 2 more. Right? Then what do we have? The bottom will be 2b, top will be b, right? Then inside the cube root would be what? 4b squared, right? Then don't cancel these 2 and 4 because that's a radical crazy numbers, then different type as a regular number. But regular numbers you can clean up, right? So you have 2 cube root of 4b squared. That's how you do. Right? If you have b over cube root of 2b squared, what do you think? How to rationalize it? You will do what? Cube root, right? 2, you need 2 more, right? But the b, you already have b squared. You only need 1 more here, right? So, because we wanted to do is triplet right now. So, on the bottom, what do we have? We'll have 3, 2, take cube root, that would be 2. We'll have 3b, right? B squared and b, take cube root would be b. Then top with this, then cube root of what? 4b, right? Then we cleaned up the fraction. Then we have 2 cube root of 4b. That would be your answer. Is that right? Think about it. What are we doing? Dividing radicals. Then at the same time, we'll call it what? Rationalize the denominator to make the denominator without the radicals, right? If the denominator is mono, all you need to do is just make the root happen, right? Then will be the good number on the bottom, okay? However, if the denominator is what? Divided by some radical divided by what? Binomial. Instead of monomial. Mono, you can just multiply its twin or triplet or quadruple things. Then to eliminate your radicals in a denominator. But when your denominator is a binomial, you cannot do that, right? How we are going to do it? Let's take a look. Like square root of 7 divided by square root of 5 plus square root of 3. You cannot multiply by square root of 5. You will not eliminate your radicals. You cannot divide it by square root of 3 only, right? So, how can you eliminate your denominators for the radicals? You need to multiply its conjugate. Conjugate. How do you spell that? Okay, conjugate. Okay, so conjugate we did for the multiplication. What's the conjugate of square root of 5 plus square root of 3? That will be its opposite, square root of 5 minus square root of 3. Okay? The reason we are doing that, you will find out we said when it multiplies conjugate, the radicals will go away. Okay? So you need to double check whether or not it's the case. So if we do square root of 5 plus square root of 3 times square root of 5 minus square root of 3, we need to FOIL them, right? Square root of 5 times square root of 5 is a twin, which is 5, right? The root of twin is 5. This one, square root of 5 times square root of 3, same radicals, you just put things inside, becomes what? Square root of 5 times 3, right? Which is 15. And this one is plus what? Square root of 3 times 5. Then last term, square root of 3 times square root of 3 is what? 3. Is that right? It becomes 5 minus square root of 15 plus square root of 15 minus 3. Then positive and negative cancel out. 5 minus 3 is what? 2. Is that right? So we say if the crazy thing multiplies conjugate, then the crazy thing will go away. Okay? So just double check too. Right? The top you distribute will be square root of 7 times square root of 5 minus square root of 7 times square root of 3. And sometimes you get confused about multiplication as well. If they are same radicals, same square root or same cube root, then you follow the product rule, you should be able to combine them, become one single radical. Minus 21 and 2. Okay, so that would be your answer to simplify or dividing your crazy numbers, to rationalize your denominator. When the denominator is a binomial, you multiply this binomial to the conjugate, to its conjugate. Okay, so if you have 4 divided by 2 plus square root of 6, right? Same thing, binomial. Then what is its conjugate? Same thing with a what? Different sign, right? So its conjugate would be what? 2 minus square root of 6. So you will multiply 2 minus square root of 6, right? So let's check on the bottom first whether or not you can eliminate the crazy thing, right? So 2 times 2 is what? 4. 2 times negative square root of 6 is 2 square root of 6, right? Then square root of 6 times 2 is a positive square root of 6, right? Then square root of 6 times square root of 6 is what? Square root of 36. Twin. The root would be 6 minus 6. A lot of you will write the square root of 6 here. Actually, it's a 36. Root of 36 is 6, right? So cancel out the middle terms. Then 4 minus 6 would be what? Negative 2, right? So we have 4, 2 minus square root of 6, and negative 2, right? Then we can just cancel all this, become negative 2, right? Instead of distribute them, because you already have what? Factoring form, factored form, you can cancel all the numbers already. Then you distribute them, will be negative 4 plus what? 2 square root of 6. Right? Okay, let's see some more examples. So what are we doing? We are doing the division for the crazy numbers when the denominator are binomials. To rationalize them means what? To multiply the denominator by its conjugate to make the crazy numbers go away in the denominator, right? So if we have square root of 5 plus square root of 2, square root of 5 minus square root of 2, right? So how should we start to eliminate the crazy numbers in the denominator for the binomial? we will multiply its what? Conjugate. Right? Which is opposite sign for this. Then let's check the denominator first. See, you actually eliminate the crazy thing. Right? So square root of 5 times square root of 5 is 5, right? Square root of 5 times square root of 2, same radicals, you multiply inside, so that's a square root of 10. Then this one would be what? Minus square root of 10, right? The last, negative, positive, negative, square root of 2 times square root of 2 is 2. Then those cancel out, you have what? 3 in the denominator, right? Then for the numerator, you just do the FOIL, same thing. But instead you eliminate the crazy numbers, you still have some because not one positive, one negative. So square root of 5 times square root of 5 is what? 5. Square root of 5 times square root of 2 is what? Square root of 10, right? Square root of 2 times square root of 5, square root of 10. Last one, square root of 2 times square root of 2 is 2. So what do we have now? 5 plus 2 is what? 7 plus what? 2 of the square root of 10. Is that right? So that will be 7 plus 2 square root of 10 on the top. Okay, so that will be your answer. Okay, so for numbers, and same thing for the variable, you would do the same thing if you have 2 square root of m over 3 square root of x plus square root of m, right? So you do the same thing for the denominator to eliminate the radical numbers. So what do we do? For the binomial, we will multiply its conjugate. Is that right? Right? Then, so for the top, we check on the bottom first, right? So 3x plus square root of m times its conjugate. The crazy things should go away, okay? So, first term, 3 times 3 is what? 9. Square root of x times square root of x is what? X, right? Next term, n, 3 square root of x times n minus. Then 3 is 3. Then radicals, they are same kind of radicals or square root. Then you should multiply them inside together. Right? Then next one, square root of m times 3 square root of x would be 3 positive, right? M and x, xm, they are the same. The last term would be what? Minus square root of m times square root of m is what? n. Then middle terms canceled out. So you have what? 9x minus n. So do we eliminate the crazy things in the denominator? Then how about the top? Top, just one term times 2 terms. You just distribute this one to everything inside, right? So 2 times 3 is 6. mx is mx, right? Combine the inside for same kind of radicals. Then next one will be minus 2. Square root of m times square root of m is what? M itself for the root, right? So that would be your answer. Okay? You need to practice to connect them. Okay? So that would be our division for the section 9.5.